All right, so in assignment number 5, we're going to continue our discussion with quadratic equations, but instead of solving them by graphing or solving them by square rooting, we're going to be solving by factoring. So let's go ahead and get started. Let's take a look at this particular quadratic equation. We could try to solve this by graphing it, but you can see the y-intercept is going to be negative 15. It's going to open up, be a regular looking parabola. It's going to take us a while to solve it by graphing it. Solving by square roots is not going to work simply because we have not only the x squared term, but we have an x term, a linear term. And so square rooting it isn't going to help us in this situation. The only way that we can really solve this equation is by factoring it. So what I'm going to do is put an x here and here, because x times x is the only thing that gives us an x squared. And then I want something here and here that when I multiply it together gives me 15, negative 15. But when I add it together gives me a positive 2. Like a positive 5 and a negative 3. Because positive 5 times negative 3 gives me a negative 15. And then my inside terms and my outside terms are 5x, my outside terms are negative 3x, and those add up to a positive 2x. This equals 0. So we factored things before, but what we haven't done is finish these if we're solving them. So for example, we have two things that multiply together to give us 0. We've talked about before how if I have two things like an a times a b that multiply together to give me 0, one of those two things has to be 0. Either the a is 0 or the b is 0. That's the only way that we can get a 0 as our answer if we're multiplying two things together. So in this particular case, either the x plus 5 is equal to 0, or the other factor, x minus 3, is equal to 0. And if it's the x plus 5 that's equal to 0, we'll subtract 5 from both sides, and x is negative 5. That's one solution. The other one, if we add 3 to both sides, x is 3, and that would be my other solution. We could check to make sure that both of these work. If I plug in a negative 5 in for x, negative 5 squared is going to be 25. Then plus 2 times negative 5 is negative 10. And then minus the 15, that does indeed give me 0. And so this one is a solution that works. If I plug in 3, 3 squared is 9. Then 2 times 3 is 6. And then if I subtract 15, 9 plus 6 minus 15 also gives me 0. And so those are both solutions that work. Let's take a look at number 2. I would try to do number 2 on your own first, and then start the video back up to see if you were able to do it correctly. So I would start by factoring. I'd have an x times an x, because x times x is the only thing that gives me x squared. And then I would have a positive 5 and a negative 4, because 5 times negative 4 is negative 20. My inside terms, that's 5x. My outside terms, that's negative 4x, and 5x minus 4x is 1x. And so now I will just set my two factors equal to 0. Either the x plus 5 is equal to 0, or the x minus 4 is equal to 0. And if I subtract 5 from both sides, x is going to be negative 5. The second one, if I add 4 to both sides, x is going to be positive 4. And so my two solutions are x equals negative 5 and positive 4. And you should check those by plugging those numbers in, just like we did over here, to make sure that those work. Let's do some more examples here. More examples of factoring. Now this one we could actually do by square rooting. I could add the 49, take the square root of both sides, and that would work. But I can also factor this. If I were to do it by factoring, I'd have x times x gives me x squared, and a positive 7 and a negative 7 multiply together to give me negative 9, or negative 49. But then a 7x and a negative 7x add up to nothing in the middle. And so then I have either x plus 7 equals 0 or x minus 7 equals 0. If I subtract 7 from both sides, my one solution is going to be negative 7. And if I add 7 to both sides, my second solution is going to be positive 7. And again, you want to check those, mentally check those by plugging them in to make sure that you get 0 as your answer. All right, so we can also solve by factoring ones like this that are a little bit more complicated. This is more complicated because we have a 3 as the a value. But the process is going to be the same. I'm going to start by having a 3x times x, because 3x times x gives me 3x squared. Then I want something here and here that multiplies together to give me a 10. So I can either use a 10 times 1 or a 5 times a 2. And I think what I'm going to do is use the 5 and the 2 first. Let's see, if I put the 5 here and the 2 here, and I make them both positive because I need a positive 10 here, this is then going to be 2x. 3x times 5, that's 15x. And 2x plus 15x does indeed give me the 17x. So then I'm going to set both of those terms equal to 0. Either the 3x plus 2 is equal to 0, or the x plus 5 is equal to 0. So this first side, the first equation, I would subtract 2 from both sides, so 3x is equal to negative 2. If I divide by 3, x is going to be negative 2/3. There's my first solution. And my second solution, if I subtract 5 from both sides, x equals negative 5. And that's my second solution, negative 2/3 and negative 5. And again, you should check those by plugging both of them in and making sure that you get a 0 as your answer. What I'd like you to do is pause the video, see if you can do number 5 on your own, and then restart the video and see if you were able to get it correct. Hopefully, if you did that, you were able to go with a 2x and an x, because 2x times x gives me 2x squared. Then I would want something here and here that multiplies together to give me a negative 12, but adds to a negative 5. So let's see. I want to try to get it right the first time. 12 and 1's not going to work. I could go 6 and 2. 6 and 2 I don't think is going to work. I could go 4 and 3. 4 and 3 I think is going to work. If I put the 4 here and the 3 here, then what I'm going to do is I'm going to make the 4 here negative and the 3 positive. Because then I have a positive 3x in the middle, and 2x times negative 4 is negative 8x as my outside terms, and a 3x minus 8x is negative 5x. And that equals 0. So I'm going to set both of these equal to 0. Either the 2x plus 3 is equal to 0, or the x minus 4 is equal to 0. So the first one, if I subtract 3 from both sides, I'll get 2x equals negative 3. Then if I divide by 2, x equals negative 3/2. And then that's one solution. And then the other solution is if I add 4 to both sides, x is going to equal 4. And again, you want to check to make sure that those both give you a value of 0 into your equation, but my two solutions are going to be negative 3/2 and 4. Let's take a look at number 6. Again, this is kind of a different one, but we can factor this. It just doesn't have a middle term. I would start with 2x and 2x. If this doesn't work, then I'd have to go back and try like 4x and 1x. But 2x times 2x does give me 4x squared. And then I'm going to have a positive 5 and a negative 5. Because positive 5 times negative 5 does give me negative 25. But then my inside terms are going to give me a 10x. My outside terms give me negative 10x. And those two things will cancel each other out, so I don't have anything in the middle, which is my case in this polynomial. So once I set them equal to 0, I'll have 2x plus 5 equals 0, and 2x minus 5 equals 0. And so here, if I subtract 5, I'll have 2x equals negative 5, divided by 2, and x is negative 5/2. The other equation, if I add 5 to both sides, I'll have 2x equals positive 5, divided by 2, and x equals positive 5/2. And so my two solutions are negative 5/2 and positive 5/2. I have one more that I want to go through with you. And in this particular case, we've also done factoring, where we factor out the greatest common factor. And that's what we would have to do here if we don't have a c value. I can factor out a 5 and an x. 5x times x gives me 5x squared, and 5x times 3 gives me 15x equals 0. So it looks a little bit different, but I still have two things that multiply together to give me 0. Either the 5x is 0, or the x plus 3 is equal to 0. So the first equation, if I divide by 5, I'll get x is 0. The second equation, if I subtract 3 from both sides, I'll get x equals negative 3. And you want to plug those in to check to make sure those are correct, which they are, and then those are your solutions. And so this is what we're going to be doing today. We're going to be solving quadratic equations by factoring. And we will go over questions that you have tomorrow in class.